Okay guys, what we're going to go through is how to balance an equation. So here we're given a simple equation for a reaction. So we've got CH4 being added to O2, and that is making CO2 plus H2O. Now, all of these that I'm given here are formulas. That is how these chemicals come. A way of thinking of it might be if you went into a shop and bought a multi-pack of crisps, you can't just open them up and take out the ones that you want. You have to take the whole multi-pack. That's what these are like. This is how these chemicals come, and we can't change anything about these numbers because that's just the way they come. But what we can do is have more of them or less of them. I could buy lots of multi-packs of crisps if I wanted more salt and vinegar packets, for example. It's another way of doing that. It's a similar kind of thing. So when we're balancing an equation, we always have our reactants, which are the chemicals that we start with, and we have our products, which are the things that are made. Now, what we need in a balanced equation is the same total number of atoms of each type of atom, so the same total number of C's, carbon, H's, hydrogen, and oxygens, O, to be in the reactants and the products, okay? So the first thing we're going to do is tally up how many of each of those atoms are currently in my reactants and products, okay? So I know that the atoms that I have are C, H, and O. I've got those in my reactants, and I've also got them in my products. I've got C, I've got H, and I've got O. Now in this example, I've got oxygen in two places, so when it comes to balancing later, I'm going to leave that one till last. So the first thing I'm going to do is write down as a tally how many of each atom are in each place. So in my reactants, I've just got one carbon at the moment, and in my products, I've also just got one carbon. In my reactants, I've got 4 lots of hydrogen. Over in my products, I've only got 2 lots of hydrogen. In my reactants, I've got 2 lots of oxygen. And in my products, I've got 1, 2, 3 lots of oxygen. So I've tallied everything up, and what I'm looking for is the things that aren't the same, the things that don't balance. So at the moment, hydrogen doesn't balance and oxygen doesn't balance. Now, because oxygen's in 2 of my different products, that's going to be harder to deal with, so I'm going to deal with the hydrogen first. Now, I've got 4 lots of hydrogen in my reactants at the moment, but only 2 lots of hydrogen over in my products. Now, the hydrogen exists over in this water over here in H2O. If I want there to be more hydrogen, I need there to be more total molecules of water. I can't just have the hydrogen bit, it comes in this packet. So if I want there to be 2 more hydrogens, and each one of these comes with 2 hydrogens, if I make it so that I have 2 of them, I can then alter my tally. So putting this big 2 in front of H2O means that I now have 2 lots of that whole molecule. So I get an extra 2 hydrogens, but I also get an extra oxygen. So I can change my tally as I go. Now my hydrogen's balanced, so I've balanced carbon because that was balanced to start with, and I've balanced hydrogen. So now I just need to look at my oxygen. Now at the moment, in my products, I have 4 lots of oxygen in total, but in my reactants, I have less, so I need there to be more oxygen over here. It comes in this packet of O2. I've got 2 at the moment, but I need to have 4. So if I have 2 lots of that whole molecule, that will add 2 extra oxygens to my tally. Now, these match, so that's balanced as well. So the benefit of tallying things up is that I can change my tally as I go. I can see that I have the same number before and after, and what I'm left with at the end is a balanced equation. I haven't changed the formulas of any of my compounds. All I've done is added in extra copies of some of them, which is fine, by putting big numbers in front of the whole formula. And that big number applies to every part of that molecule.